Hello, everyone. Very happy new year and welcome to the spring 24 semester of Introduction to Deep Learning. Today, we'll talk about the flow of the project. So while this course has multiple homeworks and assignments, which help you practice the concepts that you learn in the lectures, the project exists so that you can demonstrate your learnings in a completely different problem of your own choosing. So the whole idea for the project is that you can choose a open-ended problem. You scope the problem yourself, you find corresponding data sets and prior state of the art, and finally you use your knowledge and the learnings from this course to find a model, to train a model better than the state of the art. Now, if you can successfully do that, it's great, and we can even have we had publications in this course before coming from course projects. But even if your model is not able to reach cross the state of the art performance, you can still get good marks because we grade you on how you demonstrate your learnings rather than the success or failure of any particular model that you train. So, how do you choose your project topic? So your topic can be any novel research problem. You can also try re-implementing any recent paper from conferences, uh, or you can, start an investigation into anything which has not been published but has been discussed a lot in recent times. Or you can pick up a real problem, try to find a solution to it. This may not be a typical research, but the solution should still require a lot of implementation and planning. So this is how a typical structure of your project would look like. Now, please note that you cannot simply pick up an open source code, train it on a pre-processed data set, or maybe have ready-made weight checkpoints for your model and simply run the code and get some results. You do have to implement as much as possible, because only when you implement your own architecture or your own training pipeline can we actually see how much you have learned from the course. So when choosing a project, you'll have to choose what are your objectives and why are those objectives relevant in today's world. What has been the previous state of the art in that area? What research gap have you identified, and hence that becomes ties back to your objective? What data sets are already available? Now here we recommend to go beyond the Kaggle data sets. Kaggle provides you very properly cleaned and pre-processed data. You should at least look at data sets coming from academia or industry, which do come with an accompanying pre-processing code, which may or may not be relevant for your problem. Because sometimes you'll find data sets exactly for your chosen topic. Sometimes you have to pick up a data set from a adjacent area, and hence you have to actually change the pre-processing code for that topic. And sometimes you also may have to crawl the data from the internet. So your data set, your data acquisition strategy should start as soon as possible. You don't necessarily need deep learning expertise here. You require more of the generic coding skills and some ingenuity to find and acquire data. Once you have figured out what data sets you will be using, you need to decide upon a baseline architecture. Now, here you can use an existing open source code from any of the recent papers. Um, if such a paper does not come with a source code, you would have to implement it yourself. Either way, you should understand every line of the code in the baseline architecture, because moving on in your ablations, you would try to change the architecture of your model, or you might even try to change something from the training pipeline. And to do that, you should understand your baseline architecture very well. So once you do those ablations, you reach a proposed architecture, which, if you're successful, will have much better performance than the state of the art. And then you have to choose, how do you compare your proposed architecture with baseline? What evaluation metrics you use? How are those evaluation metrics meaningful? And what is the impact of your overall project? So once you've chosen your project topic, you also need to simultaneously look for teammates. It would be good if your teammates have a diverse skill set which complement each other. Um, but do check how much time, how many hours per week they can dedicate for the project. We expect teammates to roughly spend equal hours per week. And you should also check how many courses are they taking along with deep learning. So while this course the homeworks, especially the part 2 of homeworks, require a considerable amount of time. If a student is having multiple hard courses, they may not be able to dedicate enough time for the project. So how ambitious can your project topic be depends upon how much hours you have across all 4 teammates. And finally, you should also check with them in the beginning itself if they would be interested in working beyond this semester, and try to take your project idea towards a research publication. So again, going back to the project structure, your teammates, it's at least 2 out of 4 should have familiarity with the topic. That helps you a lot if most of your teammates know about that area, maybe because they are doing their masters or they have taken courses in that specific area. Some of your teammates should be good at literature survey. They should be able to prioritize which papers to focus more upon, because a lot of papers will be published on every topic. And also they should be able to distill what was discussed in that paper and explain it to other teammates. Finally, some of your teammates, at least one, should be really good at the basic software development skills which are needed to access, crawl, and clean the data sets. Finally, from a deep learning perspective, if 1 or 2 teammates are already good, they can either implement a state-of-the-art paper, or they can understand what's already out there. I mean, because even if a source code of a state-of-the-art paper will be somewhat different from what you're used to in your homework standard codes. So understanding what code is already out there is important, because only then you can actually change it to bring it, more closer to the state-of-the-art algorithms. Now, finally, if you already have some idea of deep learning algorithms here, this becomes easier because then you can test out. For example, if a paper is only implementing basic vision models like ResNet, Connex, you can see if a vision transformer might be helpful here. But again, look at the problem domain. If most papers are not using transformers, maybe it's not a good idea to implement transformer for getting a better performance. So here's something that if you already have experience with certain algorithms, it comes in handy because you can quickly test them. At the same time, if you don't have experience, you should do a bit more literature survey to prioritize which algorithms you should explore, which you think are more relevant based upon what other uh, researchers have been using in their work. Finally, again, in your results and discussion, if you have familiarity with the topic, you can better understand and explain uh, your results, and also talk about why certain evaluation metrics um, were a better metric for the performance comparison than others. Finally, project mentor. So you can choose any professor or a PhD student or a postdoc student here in CMU for your project mentor. We also you can also choose one of the course TAs to be a project mentor. In case you choose someone outside the course staff, we will still assign a TA to be a project mentor, just so they can handle the logistics for you. When choosing a project mentor, again, you should look at their area of expertise and their current area of interest. Sometimes people have their core expertise in one area, but they are trying to move towards a different area. So if you align with the area of interest, they might be able to spend more time with you. So yeah, check how much time they're willing to commit for you. We recommend having at least 1 hour meeting once a week. That way you can keep in sync and keep moving the project fast enough. At the same time, we also recommend having some sort of Discord or Slack group with your mentor. That way, you don't have to wait for the weekly meeting. You can actually, if you face any blocker, you can have a quicker communication with them. And also just check with them how involved would they be. And then different mentors have different style. So some would like to meet more frequently, or some would want you to set up a meeting only when you have some problem which you need to discuss. And most of the time, they would want to work asynchronously. Uh, in case your team does not, in case the skill set of your team doesn't cover the entire range, the entire skills that you need to successfully deliver a project, here uh, you can look at the skill set of the mentor, which can complement the gaps in your own team. So this slide is basically a duplication of the 2 slides ago. But you can see that if you are not very comfortable in, let's say, deep learning algorithms, if all four teammates are doing, for all four teammates, if this is the first course in deep learning, you can look at a mentor who can probably tell you which algorithms you should start studying and maybe share some sample code for those algorithms. That way it becomes easier for you to implement those while you're still learning them in the course. So this selection of topic, teammates, and mentors, this will probably go in a couple of iterations. You might choose a certain teammates and then you have to change a topic, or you have some discussion with a mentor, and then you might have to slightly change your topic area. So these things will iterate, but if you have enough discussions before your very first project proposal submission, uh, it will become much better, and everyone will be in sync, and you'll choose a topic which has much higher chances of success within the constraints of a semester. So now I'll hand over to Dennis, who will talk more about the project milestones in terms of submissions.
Yeah, so having selected your project topic, your teammates, and your project mentor, we expect you to come up with a project proposal where you'll tell us about the problem that you're interested in solving and why you think that problem is important. So we expect this to be very brief, not more than 2 pages, where you will have an introduction section, which basically introduces the problem and tells us the importance or the significance of that problem. Then we expect you to do some literature review where you try to read around the topic and find works that are similar to what you're trying to implement, and develop a baseline model or ideas from these research papers that you've read. Then we also expect you to select a dataset. So a dataset is really important to the topic because it determines what you'll be doing. So whether the whether the dataset exists or not will have a significant impact on your project, because if the dataset exists, then you can quickly get running. But if one doesn't exist, you'll have to develop your own, and that involves a significant amount of work, and so the team will have to spend some time doing that. So once you've submitted your project proposal, you can spend a couple of weeks working, and then we shall expect you to hand in a midterm report. So in this midterm report, we again expect you to have an introduction section. So here we shall expect you to go more in depth in terms of problem description and significance, and also tell us why it is very important to work on this topic and how it is related to deep learning. Then we expect you to have a literature review. By the midterm report, we expect that you will have done an extensive study of works around your area of interest and have come up with something very comprehensive that you can present. So in this section, we expect that you don't just state what you've read in the papers, but group together similar methods and try to explain why they might have worked, why they may not have worked, and ways of improving those methods. From there, you can select a baseline. So we expect that you'd at least have a baseline model in your area of interest. So in terms of baseline selection, expect that it should be something that was developed recently. So don't look out for a model that's very old, because that means it would be weaker compared to the most recent methods, and you won't do that much work to beat its performance. So expect that you'll select a good baseline model. Then we also expect that by the midterm report, you'll have implemented this baseline and obtained results. Obviously, this depends on whether the baseline was available or not. We do not have a restriction. So if the baseline model provides the code, you can run that code on your dataset and provide an analysis of the results. But if it doesn't exist, you are expected to implement the baseline and provide the results. Then from the analysis of the results, you can tell us what went wrong and why you think it went wrong, and possible improvements that can be made. So this goes into the proposed extension section. So we expect that here you have an idea of a concrete idea of what you want to do in the project, and that's what we expect you to describe in the proposed extensions. Then at the end of the project, we expect you to present a final video. So in this, it's a 5-minute video where you basically present a summary of the entire project. So in this video, you can start with the problem description. So you have to briefly tell us the problem that you're trying to solve and why you think it is significant or why you think prior methods have failed. Then you have to describe your implementation. So what did you do? Did you use CNNs, use transformers, use RNNs? You can describe your implementation in quite some detail. Then you must compare it with basically your baseline. So if you're still using the baseline that you had in the midterm report, you can tell us about briefly about the baseline and compare the results that you got to those in the baseline. So then we expect you to describe a bit of your results. So yeah, you'll have to tell us whether you improved on the baseline or not, and then tell us if you made improvements. You could hypothesize on what resulted in those improvements. And even though you didn't manage to make improvements, you can then tell us why you think you didn't make any improvement. So your project won't be judged based on whether you made improvements or not. So we are judging your methodology in terms of how you worked on the project. So you don't have to necessarily beat the baseline model. So we shall also be assessing your project completeness. So ensure you've in the video in terms of your explanation, you should show us that a significant amount of work has gone into the project over the course of the period you'll be working on it. Then we shall also be judging the correctness of your findings. So don't just come up with things to talk about in the video, except that these things are verifiable, or there is another paper or article that corroborates your findings. Then finally, we have a project report. So in this project report, after the final video is presented, you can go ahead and maybe run more experiments if you had not concluded these experiments by the time you presented the final video. So in this project report, we shall have still similar sections to what we had in the earlier ones. So we shall have an abstract. We shall have an abstract. So in this abstract, you will so basically the abstract is a summary of the entire project. So you tell us introduction, that is, tell us the problem you're trying to solve, why you think it is important, the methods that have been used in the past, and the kind of improvements that you're looking to make. Then you can have an introduction section which goes more in detail in terms of talking about the problem and the methods that have been used in the past. Then the related work section tells us groups together methods that have been used to try and solve the problem. So for instance, if you can compare RNNs, that is LSTMs, and attention models. So try to group together each approach. Each approach, let it have its own paragraph. Then you can have the methodology section. So basically here you can talk about your data set, its components. So in terms of, for example, if you have a speech data set, so you can talk about the speech, and then the transcriptions that you had for the speech, and then the types of tasks that can be done on this data set. Then you can also tell us why you selected this particular data set for your task. Then we expect you to have a section where you describe experiments you did, that is tabulations you ran to determine the importance of different parts of your model. Then you can describe the results you got and then have a discussion of the results. So in this discussion, you can tell us, oh, I think I made this improvement, and tell us the source of the improvement. Or if you didn't make an improvement, you could also hypothesize on the reason as to why you didn't make an improvement. Then we also expect you to have the evaluation to describe the evaluation metric. In this, we expect a mathematical form of the evaluation metric, and then also qualitative description of the evaluation metric and why this metric matches the task at hand. From there, we expect a conclusion. So conclusion here, basically you bring everything together and tell us from the description to the method you use to the results you obtained and the future work, future directions. So where do you go from the project? Then you also have to have a reference section. So references are very key in terms of scientific study because all the work we're doing is based on someone else's work. So it's always important to make a reference to their work and not take it as your own. Thank you very much.